Guten Abend. What I'm going to look at this time is the distance-time relationship, specifically converting numbers into graphical information and vice versa. Right, okay, so I've laid out three lots of axes. This is where you've got your y-axis, and this is where you've got your x-axis. Remember, some people choose y to the sky to remember that, and of course x is across. X is across. I like that, to be honest. So, if we talk about maths before we discuss distance-time relationships, we know that the gradient is always calculated, usually, on a graph by doing the y value on the axis divided by the x axis. Okay, so if I have got a straight line coming from the origin here, and if I've got my gradient, then whatever the length of that y value is, divided by whatever that length of that x value is, okay, is your gradient. So your gradient is equal to the y value, or change in y, as I've drawn on there, divided by the change in x. Okay, why is this relevant? Well, I'll tell you why it's relevant. If we do the equation that is speed equals distance divided by time, and we have got speed on the graph represented as distance divided by time, then that means that your gradient is represented by distance divided by time. So therefore, if you calculate the value of your gradient, you calculate the value of your speed. And it's true for calculating any equation where you've got y divided by x on a graph. So for example, resistance being voltage divided by current. If you have a VI graph, you could calculate the resistance that way as well. So, if we've got a distance time graph, and we have got a journey represented like that, okay, then here the gradient is shallow, here the gradient is steep, and here that gradient is flat. I'm not going to label that as a straight line because that would be misleading. Okay, so here the distance at this point is not changing, so that is stationary. That means that the object is not moving. Here, in terms of this steep line, okay, it is going at a faster speed than this by comparison. You can judge that by eye. So if you asked by eye to comment which bit is faster, then you would say it's the one with the steeper gradient. If you were asked to calculate a speed after the stationary part, then you would simply read off the length of that value on the x, read off that value on the y, and it'd be y divided by x. For those of you who are doing the higher paper in physics, well done. If we have an object that is speeding up, also known as accelerating, then you would see a shallow gradient turn steep like that. So travelling slowly, slowly, getting faster, we're going from shallow, shallow, shallow to steep, 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 steep. So this represents an accelerating object. Now you could be asked to calculate the gradient on a curve, okay? Now, you will need your ruler, and what you would do, if you were, say, to calculate the speed at that point on the curve, you would draw a tangent. Now, what you do is you make sure that your gradient hugs the curve as much as you possibly can, and you make your own straight line. Now, in an exam, there is a degree of tolerance, so there's a range of acceptable answers because people will draw different straight lines. And what you would do, as you would do in a normal situation, change in y, change in x, speed equals distance divided by time. And that, everybody who's watching, is your tutorial on distance time graphs. See you later.